All right, guys, last video for today. You guys are doing awesome, I'm sure. Other discontinuities. So we've looked at holes, right? Things that make it undefined at a specific spot. But we're going to talk about those asymptotes, those walls that the graph cannot cross. Because of the fractions, like hopefully you noticed, the only time there's a hole is when you can cancel two things out. Right? If you're watching picture-in-picture right now, watch. The only time there's a hole is when you can cross two terms out, top and bottom of a fraction. Other than that, if you can't cancel things out, there's an asymptote, a wall that your graph can't cross. So let's look at these two. Y equals 1 over x plus 3. Look, there's nothing that got canceled out. Like, I can't cancel these two terms because they're not factors. It's got a vertical asymptote at x equals negative 3. Why at that place specifically? Well, because if you put a negative 3 in here, what would happen? It'd be undefined, right? We'd have 0. So we don't want that. So if you look on this first graph, 1 over x plus 3, this dashed line, we use a dashed line to represent that wall that it can't cross. You don't have to draw a dashed line, but number one, it looks cool, but it makes it extra clear. So notice how this graph does not cross that line. It gets infinitely close to it, but never crosses over it. Because if it did, literally it can't. It would be undefined. I guess you could draw like that, but you would be wrong. So don't do it. Same with x minus 3. It has the asymptote at x at positive 3. Notice these look like the ones we just did together, right? I mean, they're kind of arc-looking on the two sides. They go through 1, 1 relative to where the new y-axis is. Let's try one. F of x equals 2x plus 1 over x squared plus 3x plus 2. Well, I see some factoring what we got to do. 2x squared plus 1 over x squared plus 3x plus 2. This can factor into x plus 1 times x plus 2, I believe. You know what? This is a bad example. Here's what I'd like you to do. I apologize. My brain has been crazy the last couple of days. Will you please try it on Desmos and see what it looks like and graph it and see if you can figure out the connection between the two. This is a little bit harder than we need to do right now, but that's okay. Let's do this last one here. So let's go back. Pause the video and try it and then come back, okay? Let's keep going. We're not going to use Desmos for this one. We're just going to talk about it. If you want to, you can try though. These are the two graphs, the two parts of the equations from the one above, right? X plus 3, x minus 3 on the bottom of the fraction. We're multiplying them. Well, if you multiply them, you'd have 1 over, right, fraction straight across. X plus 3, x minus 3. We got two asymptotes. One at negative 3 and one at positive 3. So what does that mean? Well, just like before, our graph kind of looks the same. It's got the two arc-looking things, I guess, like that. But using the two outside asymptotes. Get your asymptote outside. It's a nice day. Right? So it'll look kind of like so. Kind of like this, at least for part of it, right on the outsides. Now we have to really stretch our brains for a second. So I'm going to sit down. Imagine you're traveling on this line. As you're coming down here, you're getting closer and closer to that asymptote. And we're going off the page, and we're going forever, and we're going around the universe out to infinity, right? We're going forever and ever and ever and coming back. How are we going to eventually meet up with this guy? Well, eventually we'd come back and kind of turn around and go like this. And then come back down. and continue around and around the universe back again before we can meet up with this guy and keep going. So think of it, he comes down, meets over, comes around, and goes back. That one's a little weird. We're going to talk about it a little bit more in depth. That was probably a terrible explanation, but it's kind of cool looking. So if you have a question about this part specifically, please write it down right here. I mean, my question is, how do we know this? How do we know what the middle looks like? Maybe look it up. Do a little Google search. Type up those typey fingers. How do you know what that middle looks like? Or if you have a different question, write it down. Let's do one example together on the back here. I don't think it's asking you to graph here on the back. It just says identify the vertical asymptotes. So what's the asymptote value? Well, let's look. This first one, this bottom one does factor, I believe. Try it on your own. What multiplies to 60? 7. 6 and 10. No. What does? 5 and 12? I think 5 and 12. 5 and 12, specifically x plus 5 and x minus 12, right? So if we rewrote this, you'd have 2x plus 5 over x plus 5 and x minus 12. Now, can you cancel these two out and like create a hole in your graph? No, just because there's a plus 5, no, you can't do that. There's a 2x plus 5 and x plus 5, no. But this does mean you have an asymptote, I usually just ASYMP, asymptote, at x equals negative 5, right? That would make that undefined. And x equals positive 12. That would, positive 12 would make that undefined. All right, work together on these. Identify the asymptotes. Identify those asymptotes. For the first ones, number 1 through 6 here is also find asymptotes. You've got a lot of factoring, maybe some GCF, top and bottom going on. On the last 4, identify whether it's a hole or an asymptote. So remember, hole. If you can cancel something out, it's a hole. If it's just on the bottom, it's an asymptote. All right, guys? Try your best. I'll post a couple other videos that help explain if you want to watch those as well, but I think you can give these a try. Work together. You guys are smart. Remember, we're mathematicians. We can do anything we want. Have a great weekend. I'll see you on Monday.